Okay guys, in this video we're going to review a couple of graphing problems. That is to say, if I were given the equation of a trig function, could I work towards what its graph would look like? And so we're going to review really quickly here just some of the parts of the equations of trig functions, but you're going to see me do this. You're going to see me list it in terms of a sine function. So one thing I want you to keep in mind is I didn't have to use sine here. I just chose to use sine as my example. This could just as likely be a cosine or tangent or any of the reciprocal functions. So using this sign here, what I want to do is basically be able to identify its parts, A, B, C, and D. And so some things. A is always the coefficient of our trig function here. And so when you look over here at this that we're going to graph here in a moment, we say 1 plus 2 cosine 2x. A big misconception that I see a lot of the time is that people try to tell me that the A value here is 1 just because it's the number in front, when truly A is the coefficient of our trig function. So in this case over here, I think it's fair to say that our A value is 2. And so while I'm on that topic, what I do want to point out is that sometimes, and I want to say sometimes, many times, sometimes it is written like this: y equals d plus a sine bx minus c. So don't trust that the a value is always the front number. It is always the coefficient of our trig function. Now a being the coefficient of our trig function means that b is the coefficient of our x value on the inside of here and was directly related to the period of our function. Now c and d are these constants that we see. It's just that with this constant c, it is a bundled constant in here with our x, and so going to be responsible for left and right shift, and then d is going to be responsible for our vertical shift. So as a matter of review, what we want to write down are these things in terms of the amplitude of the graph. And this is really, when we talk about the framing method of graphing, yikes, let me fix that here. This is the height of our frame. So the height of our frame is the amplitude, and we say that that's always the absolute value of A. Now in terms of the length of our frame, this is the horizontal distance we have to go before our graph starts to repeat. We refer to this as the period, or at least we could say P. Now in terms of P, we want to write this here. The period is always going to be, in most cases, 2 pi over B, but it could be pi over B if tan or cotan. Okay, so that's important to keep in mind here. In general, we're saying that we're taking the period of the function and we're dividing it by B. B being the number of cycles that we would go through in its normal period. And so we use 2 pi for sine, cosine, secant, and cosecant because their periods are 2 pi. We use pi over B because tangent and cotangent have a period of pi. Now in terms of what else I would want to know here, I also want to know my phase shift. And so in terms of phase shift, let's keep this in mind. That's a fancy phrase for horizontal shift or horizontal translation. So horizontal shift for all of our graphs is going to be at C over B, and then our vertical shift, which is just called what it is vertical shift or vertical translation, that's going to be exactly at D. So keeping this little inventory in mind here, this should help us to go set up our frames that we need to set up to make our graphs. Okay. So really quickly, let's review what these frames look like. So every frame we make tends to have this shape right here. And with respect to its characteristics, well, I would say that most frames, the exception being tangent, have what we call the starting point on the midline on the left side of the frame. So what are some other characteristics here? Well, I would say that the height of our frame is given as the absolute value of A. And so it wouldn't matter if I wrote the absolute value of A or the height. I really truly mean the same thing here. And in terms of the length of this frame here, I'm going to write the period P, but also I could say it's just the length. Okay. Now, with respect to what our graphs look like within their frames, that's going to be different depending upon how they behave around the unit circle here. So really quickly, let's take into account, what if I were to look at, say, a sine curve here and a cosine curve here. Remember that sine, and I know that I didn't put this in the coordinate plane, but if you're looking at the unit circle here, which I believe I drew in my last video, at 0 radians or 0 degrees, the value of sine starts at 0. And as our angle gets bigger and bigger at 90 degrees, at 180 degrees, at 270 degrees, and 360 degrees, you see that sine goes from 0 up to 1, then back to 0, and then down to -1, and then back to 0. So the consequence of this is that in its frame, or within its frame here, let's choose a brighter color here. How about this? The sine curve starts at a height of 0, but then goes up to 1, or in other words, proceeds to its maximum at a fourth of the way through its frame. Half of the way through its frame, it goes back to 0 again. 3/4 of the way through its frame, it would go down to -1 or at its minimum, and then would come back to its midline again. So we just want to keep in mind that our sine curves look like these S's, okay, like a sine S. When it comes to cosine, cosine is different. When we start at an angle of 0, we say, well, what's the value of cosine at 0? It's actually 1. And so what we end up saying is that cosine at its frame here starts at the top of its frame or at a maximum and then goes to the midline, minimum, midline, maximum. And so one thing that is important to keep in mind is that when you are drawing cosine curves, excuse me, it does not go through the starting point of the frame. It starts at its maximum. So would I still need the starting point? Yes, because otherwise you won't know where to start your frame, okay? So the very last amendment I do want to make here, along with this inventory right here, is to keep in mind that our starting point would normally be at 0, 0. But what if I've shifted left or right by c over b and up and down by d? What that would mean is then our starting point would be wherever c over b is, comma, d is. And so on all of these graphs here, we're basically going to rattle through and determine all of these things, but then go make a frame and drop in the shape we need. So looking at number 33 here, let's go ahead and do this. I would advise you to at least write A equals B equals C equals D equals to get a good mindset as to what these values are. So looking back up here, remember that our D value was in front this time. It wasn't the coefficient of this trig function, so that must be our D. D is equal to 1. Now A must be 2. Our b value is the coefficient of x on the inside of here, and so it has a value of 2. And then our c value is this bundled constant that occurs inside with this x here. Now when I look inside my angle, I don't notice that I added on or subtracted off anything to or from this 2x. And so we're going to say that c then must have a value of 0. So using what we know, let's go pick some things apart here. Amplitude. Now cosine does have amplitude, and it would be the absolute value of our a value. So the absolute value of 2 is 2. Now we know how tall our frame should be. How about vertical shift? Now thinking about vertical shift, remember that this is our d value here. Well, our vertical shift in this case would be 1. So we say that this graph would shift up 1. How about period? Okay, so period, 2 pi over b. Now this will give us the length of our graph, but 2 pi over b in this case would mean I get 2 pi over our b value, which is 2. In other words, the length of our frame should only be pi in length. Now phase shift, c over b. I would say take the time to write this, 0 over 2, which gives us a value of 0, which means that this graph won't shift left or right at all. And then last but not least, our scale. We'll come back and address our scale in just a moment here. What I want to do is I want to add one more thing on here, and that's the starting point. And so with respect to our starting point, the neat thing is this. It's c over b comma d. In other words, whatever we got for our phase shift is the x part of this, and whatever we got for our vertical shift, 1, is the y part of this. So I'm going to go ahead and start crafting my frame. And so knowing that 0, 1 is my starting point here, I'm going to go 1, 2, 3, 4. I'm going to go up here and I'm going to write 5 right there and down here at -5. But because I want you to know that I'm counting by ones on my y-axis here. So 0, 1 would be this starting point right here. Now the two things we need are the height and the length. So always start with your height. The height in this case would be the same as our amplitude here, 2. So I'm going to go 2 up, and I'm going to go 2 down from a height of 1. Now what that does is it places us at a height of 3 and a height of -1 when we look at where our frame goes up to and down to. Now in terms of the length of this is pi. Keeping in mind that I have to make a frame with 4 columns in it, you know, I might say, let's make this right here pi, because I have 4 columns that I could fit into my frame here. You might also be so bold as to say, well, you know what, I'm going to make this out here. I'm going to make this pi, and these are my 4 subdivisions of my frame. Sorry, let's try that again. 1, 2, 3, 4. We'll make this one pi, and then I'd have my 4 subdivision. In this case, I'm going to go ahead and say, let's call this line right here pi, and I do need to label this. But with respect to my frame, we're going to say I had the left side of my frame. Let's go out to this point here. This would mean that the length of my frame going from 0 to pi is a length of pi. From here, we have the height, the starting point, the height, the length. All we need to do is just kind of piece together the rest of our frame. So here goes my midline. We'll split it in half. We'll split the halves in half. I'll tell you what, folks, from here, we just need to fit the sine curve inside of this. And so we're going to go ahead and fit this basic shape of sine inside. You just need to be aware, though, last thing, should this be reflected? And because our a value is positive, it is not reflected because a is positive. Not because the amplitude's 2, but because a is positive. So I'm going to start at my starting point, go to my maximum, back to my midline here, down to my minimum, and back to my midline. And here's the deal. This would be our trig function right here. Okay. So the whole emphasis is going to be placed on making the frame. Now, for number 35 here, I want everybody to notice a few things. The first is that it is a cosecant function. And so I'm going to have to change my color here. But remember that cosecant is the reciprocal of sine. And so it's worth saying that if I'm graphing y equals the cosecant of x, I'm really graphing 1 over the sine of x, meaning that wherever this is at a height of 0, if 0, then asymptote. Okay, we're going to have an undefined point on our graph. So when you look at the frame of, say, sine here, I'll switch to, I need something different here, you guys. There we go, purple. I know that wherever the sine curve is at its midline, my cosecant curve is going to have an asymptote on its graph. And the same goes for this over here. Wherever it's at its midline, I have an asymptote here and I have an asymptote here. So as far as what the behavior of this graph is in between these asymptotes, remember that what we get are these little curves that come down between our asymptotes and they touch our original sine curve at the crests and troughs. And they share these points here at the crests and troughs. And so here would be altogether our cosine curve that goes through that cycle right there. So you'll notice it has the same cycle length, same period. It just doesn't have an amplitude this time. Looking at cosine, it would share this crest point and be half of our little swoop here. It would share this trough point and be half of this little swoop here. And then we would say from this crest we get the other half of this. So you can see that it goes through the full cycle of secant here. If this was a secant graph we needed, we would reciprocate cosine. So the point of this story is that if you are going to graph for me, if you're going to graph this, we really need to graph this first, 1 plus the sine of pi x, because if I know what the sine curve looks like, I know what the cosecant curve has to look like around that. So let's go and start with this amplitude. The first thing you're going to see me write here is specifically none. Now, I mean none for the cosecant curve, which is what we're really making. But the amplitude of this sine curve would be 1. So I think it's fair to say here that the absolute value of 1 is 1. We're going to make a little note here. This is our frame height. We at least want that, but you're going to tell me that this has no amplitude because cosecant and secant don't have any amplitude. Vertical shift, well, do we have a d value here? So I'm kind of getting ahead of myself. Maybe we should write these down. A in this case is 1. B in this case is pi. C is 0. We don't have a constant in here bundled with x, but we do have a loose constant outside is 1. So our vertical shift in this case is going to be 1. Period. Well, 2 pi over b would mean I get 2 pi over, in this case, pi. So this is a weird thing, but we get a frame length of just 2, no units of pi here. Phase shift would be c over b. So our c value, 0, over our b value, pi, gives us no left and right shift, and then scale. We'll hit scale last here. So with respect to this graph, let's go ahead and start with our starting point. Remember, your starting point is always going to be at c over b, which was our phase shift, comma d, which was our vertical shift. And so this graph here is starting at 1 again. I'm at least going to label a scale on my y-axis. I'm going to start at 0, 1. I'm going to tell you that I'm going by 1s here. So 0, 1, let's talk about frame height. Now the frame height is 1, which means I'm going to go above by 1 and below by 1, which means this graph here, its frame reaches a maximum height of 2 and a minimum height of 0 in its frame. So we've got the height part. Let's talk about the length. Now the length is 2. So we're going to have to pick a spot out here to call 2. And so maybe what I do this time is just to show you I could use this notch mark, the 4th notch mark. We'll call this 2. That would mean my frame goes out to here, to here. And so let's put on our midline. Let's cut it in half. Let's cut these halves in half. And here's going to be the secret. So let me switch to like a red. We're going to start by putting our reciprocal of cosecant curve in here. In other words, our sine curve in here. So my sine curve would have looked like this right here. It would have looked like that right there. But keeping in mind we want cosecant, here's what I need you to see. Wherever this graph is at its midline, which means here it's at its midline, here it's at its midline, here it's at its midline, we have asymptotes that go on this graph here. And in between these, we would say that the graphical behavior is such that it touches the crests and troughs, but then turns back around. And so this would be our cycle of our cosecant curve here. So the last thing I wanted to talk about is just scale. When we talk about scale, what do we mean? It's not that important to me, to be very honest with you, but scale just means what are you going by on your x-axis. And so if I'm calling this notch mark here pi, that means that it took 4 of these to get up to pi. Each one of these is a pi fourth. So our scale here in this case is pi fourths. Whereas here, I went all the way out to 2 here, and it takes 1, 2, 3, 4, 5, 6, 7, 8 of these notch marks to get up to 2. So each of these is about 2/8 long, or a fourth of a unit long. So I'm not so worried about this as much as I am about your graphs, but keep in mind you want A, B, C, D. Use this inventory to help you out, but it's all about making the frame and then fitting your graph inside the frame. Cheers.